stage 2 is a structural assessment. So you're not just looking at the building now, you're actually doing some numbers, or will do. So it's a qualitative assessment of the structure. So does the building have any known faults or defects? And that's the first questioning of the building owner or building operator. They may or may not know about the defects, but it's worth questioning the people in the building as to how long these cracks have existed, or how long they've had a leaky roof, for example. So are the defects new or are they time-related? So is it time-related deterioration, like rot is a time-related deterioration, corrosion of your steelwork is a time-related deterioration, carbonation, these all occur over a long period of time. So you can then assess the rate of decay, and from that, the expected life of the building, potentially the time to failure. Has the structure been damaged by earthquake, fire, or impact, or even these days, flood, or the things that come with flood? As you saw recently, it's not the water that does the damage, it's what the water brings. Now, I mean, in almost every flood, you'll get a lot of silt coming in, causing a fair amount of damage and debris. And in New Zealand, we've seen what they call slash, which is forestry debris, which is washing down, large lumps of wood washing down and crashing into things, causing quite a bit of damage. So these can impact on your cladding and may even impact on your timber structure, for example. So you need to assess the damage that these events have done to your building, and is there a potential for collapse? And if that, for example, a component of your building is looking like it's failed, can that load be shed elsewhere? So is there redundancy in the building? Can we have alternative load pipes? If not, will the failure of that damaged element cause failure? In other words, so hence you're looking towards progressive collapse. So what are the modes and consequences of structural failure? And that leads on to, is it disproportionate to the cause of failure? So the bottom half of flowchart 2, structural assessment. And we go again, is it robust? Is the robustness adequate? And if we say, if we go down the positive route, yes, 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 then we should be ending up coming back to writing our report. If we go no, can we look at either the loading or the forces being changed? Can we look at changing the factors of safety? Can they be reconsidered? Then you look at, is your analysis model that you've used before, is it too simple? We often use simple beams, simple frames and so on, simple trusses. Is it too simple? Is your model too conservative? Have you undersized components? Have you taken a lower grade when you could have taken a higher grade? So if so, then yes. So yes, you go on to in situ testing and what I call advanced analysis. That will be flowchart 3. Once you've gone through that process of stage 3, you come back to this flowchart and conclude whether it's stable, robust, and fit for purpose. If yes, then you can deem it adequate. If not, do you limit the building use? Do you say it's beyond repair? If yes, then you need to say so. Or are there any temporary repairs required or temporary works required?